Why don't groundwater basins follow surface topography? Imagine walking across a hilly landscape and expecting the underground water flow to match the ups and downs you see on the surface. It might seem logical, but in reality, groundwater often does not follow the shape of the land. This is because underground water moves through layers of soil, rock, and other materials that are quite different from the surface terrain. These underground layers, called aquifers and confining layers, determine how water flows beneath our feet. The flow of groundwater is mainly controlled by how permeable the underground materials are. Some rocks and sediments allow water to pass through easily, while others act like barriers. When water encounters an impermeable layer, it can be diverted or trapped, creating underground pathways that do not match surface features. This means groundwater can flow around hills or beneath valleys, ignoring the surface shape entirely. Another key factor is the pressure within the underground water system, called hydraulic head. Water moves from areas of high pressure to low pressure, which may not be directly related to surface elevation. Sometimes, groundwater can even flow uphill if the pressure gradient pushes it that way. This is very different from surface water, which always flows downhill due to gravity. The water table, which is the top of the underground water zone, can also be quite different from the land surface. In some places, the water table follows the land's shape closely, but in other areas, it can be offset by many meters. Large-scale geological features like faults or fractures can also redirect groundwater flow, making it cross surface boundaries. Recharge zones, where water enters the underground system, and discharge zones, where water exits, do not always line up with surface drainage divides. This means that groundwater can be recharged in one watershed and then flow into another, crossing surface boundaries. This is important for managing water resources because it shows how interconnected surface and underground water systems are. Understanding that groundwater basins do not follow surface topography helps us better manage water supplies and protect ecosystems. Contaminants can travel beneath surface divides, affecting water quality in unexpected areas. Mapping groundwater flow requires more than just looking at surface maps. It needs geological surveys and measurements of underground water levels. In short, groundwater flow is shaped by underground geological features and pressure differences, not just the land's surface shape. Recognizing this helps us understand how water moves beneath our feet and why managing it requires looking beyond what we see on the surface.